Hello everyone, welcome to part 12 of this ongoing series on operating systems. So this video is basically a continuation of the previous video where we talked a bit about system calls. So in this video we'll be talking about the various types of system calls. So system calls can be broadly classified into these six categories here. We have system calls which are meant for process control, file management system calls, device management. We have information maintenance related system calls. We also have system calls to facilitate communication and also protection. We'll go over each of these points and see what are examples we have for each of these categories. So when we talk about process control related system calls, these are some of the examples here. So whenever say there is a process running, it would basically end at some point. So these two are basically talking about process termination here. So if the process is terminating normally, then there would be a system call like end which would be issued. And if at all there is an abnormal termination, then we would issue this abort system call. Also, we have load and execute. So some programs might be like requiring to load one program and then execute it. So that is basically what these two would do. They would load and execute another program. And we also have create process and terminate process system calls. So when we say create process, there might be like a process which would basically create another process. Like for example, this fork is an example where a parent process would create another child process. So this would be an example for like system call for creating a process. So in Unix related environment, we also have exit, where the created process gets terminated basically. And also there might be cases where we would need the attributes of processes, or we might want to like set the attributes of processes. So assuming there is an environment where we have created multiple processes, and in that case we would want to like have a control on their execution. So like for example, we might need to like modify the priorities of the processes. So we might want some processes to be like running first, and then some other processes to be like running second or something. So then in that case, we would have to like get this priority, which is like a process attribute. So we can get this priority of the process with get process attribute system call, and we can also set the priority using this set process attributes system call basically. Apart from that, we also have a system call which allows a running process to run for some specified amount of time. So this wait for time or wait time system call would wait for some specific time, and it will allow a running process to run for that particular time. Similar to wait time, we also have wait event, which like is a system call which would wait for some event to get triggered. And also there is the signal event. So signal event is like a system call which a process, like for example, process should be like able to signal some kind of like it should signal whenever some kind of event triggers. So the signal event would be the system call which would be issued by the process to signal the event. And there is like a system call which is also meant for data integrity. So assuming there are two processes which are sharing common data, then in order to maintain this data integrity, there is this acquire lock and release lock system call. So one process should like in order to access the data, it should acquire the lock first. And once this lock is like acquired, the other process cannot like access that data until the lock is like released by the first process. So these are some of the system calls which are like more related to process control. We also have system calls which are more towards file management. Like for example, there is a system call to create file, delete file. We also have system calls to open and close the files, to read the file, write the file, and reposition the file. So when we say reposition, it is basically repositioning the file pointer. So you can actually like read the file again from some we can like rewind the file pointer to some previous point and then read again. We can also like reposition the file pointer to like skip to end of file basically. So this is what this reposition system call does. And we also have system calls which are related to like getting and setting the file attributes, similar to what we had here in process like get attributes and set attributes. File attributes could be like file name, for example. Say you want to change the file name, then you'd basically call the set file name file attributes system call. And also we have move and copy system calls. So move would basically copy, move one file to from one location to another location, and copy would copy the contents of one file to another file. Similar to file management related system calls, we also have device management system calls. So when we talk about devices, these are nothing but resources which are controlled by operating systems. So when we talk about devices, they can be actual physical devices, or they can also be virtual resources like files. So similar to file management related system calls, we also have like device management system calls. So when we talk about file management system calls, we already discussed that there is a system call issued to open the file and close the file. So similarly, we also have a request device and release device. So request device system call would basically request for the usage of a particular device, and release device would like release the device once it is used. So if at all there was no such mechanism of requesting and releasing devices, then the system would basically enter into a state which is called deadlock. So we will deal with this deadlock in the future videos. And apart from this, we also have similar system calls like read, write, reposition, and get attributes and set attributes for devices. Yeah, there might be like system calls which are issued in order to transfer information between a user program and the operating system. So, for example, in the user program, you might want to like get the time or the date, or if you might want to like set the time and date. So you can like do that by issuing system calls to get or set the current time and the date. You can also like get and set the system data basically. So system data is nothing but like for example, you can know the number of current users, and you can also like get to know the operating system version number, etc. We since this is like the attributes are like more towards this information only. So process, file, and device attribute getting and setting is also like put under this bucket of information maintenance. There is one more special system called this dump. So this dump would basically like dump the entire process related information, and we can actually make use of the information for debugging any issues. So so basically, you can call this dump whenever there is an abnormal termination, and you can see the dumped information to just debug the issue basically. Yeah, so this dump is more into this like debugging issues. We also have system calls which are more related to facilitating communication. When we talk about communication, it is basically the communication between two processes, but it can also mean the communication between two computers in, say, like a network. So the inter-process communication, or the IPC, it is basically done by either of these two models. So we have two kinds of IPC models. One is this message passing model, which is also like popularly called as a client server model, and we also have a shared memory model. So in case of memory, message passing model, here two processes communicate with each other by like exchanging messages. So say process one wants to communicate with process two, then they just like exchange messages for this communication. And this message exchange happens via a common mailbox basically. So there is a common mailbox, and this common mailbox would facilitate this message exchanging. And whenever two processes want to like communicate between each other using this particular model, they would have to set up a connection between them. And that connection setup can be done by this open connection system call. So sender process would basically open the connection, and once the connection is opened, the receiver process would have to accept that connection. So that is basically done by this accept connection system call. Now assuming there are like multiple processes in the system, so process P1 wants to communicate with process P2. So in order to like identify this process P2, there must be some ID which is associated with process P2, which P1 should know. So we can like know the process IDs by making use of a system called, say, this get process ID. Similarly, in case one computer wants to like talk to another computer in a network, we have this get host ID system call. And once this like connection is set up, messages can be exchanged using this write message and read message system call. And once like the communication is done, we can close the connection calling this close connection system call. Apart from this, we also have another model called this shared memory model, where two processes who want to like communicate with each other basically make use of a shared memory region. So the sender process would basically create a shared memory, and the receiver process would have to attach itself to the shared memory, and basically the communication would happen via the shared memory here. Normally, operating systems don't allow one process to like make use of some other process's memory. But if at all two processes are communicating using this shared memory model, then they must agree to remove that particular restriction and then proceed with the communication. Next up is the protection related system call. So when we talk about protection, this is more about controlling access to the various resources which are like provided by the computing system. Resources could be like IO resources, or they could be logical resources like files. So for example, we can like set permission and get permission of a particular resource, or we can also like allow a user to have access to a resource, or we can like deny some specific users like access to like some resources. So this is more about protection related system calls. So yeah, that's it I had in this video. In the next video, we'll be talking about system programs, and we'll see how system programs differ from system calls. Yeah, so thank you for watching.